In this video, we're going to bring together the things that we've talked about in the last few videos and write a completely new class from scratch. We're going to write a class to store the information required by a town to provide information to an electronic population sign, the sort of thing that you see outside some towns in America. The sign's going to have the name of the town and a count of the current population. And the idea is that a program could be connected up to registrations of births and deaths and automatically update the sign every time there's a new birth or a new death within the town. We're going to follow the principles that we've talked about, which is to observe and to imitate, making adjustments where required. This is the new project that we're going to start with, and we're going to create a new class which I'll call population. Now you probably recall that one of the principles I've suggested is that we remove all of the boilerplate code that's provided for you by Bluejay inside the class, because it just makes it slightly easier to work with a blank sheet of paper rather than try to edit what's already been provided, which is not of a great use to us. Now, because I want us to follow the idea of observing and imitating, I'm also going to bring up the ticket machine project that we've been working with and have the source code of that just off to one side so that we can look at it and refer to it if we need to at any point in writing our own class. For instance, if we're not quite sure how to write a field or a constructor or what the elements of a method header are, we can always look at some source code that we've already seen and we know is correct, and then use that as a help for writing new source code in a new class. The class is going to be called population, and we know that all classes have a very similar header. We name the class after the words public and class, and then we want a pair of curly brackets that are going to mark the start and the end of the class body. So now we need to think, what data does an object of class population need to store? If we think about the sign is going to be storing the name of the town and the count of the population. So the obvious fields to define inside the class are an integer for the population count and a string for the name of the town. Now, in general, what I advise is not trying to do everything at once, but just take relatively small steps and build up a class definition in small pieces. So we'll just focus on one of those items of data to start off with. We'll just focus on the idea of keeping a count of the current population, for which we want an integer field. We've already got an example of an integer field in our ticket machine class, so we can simply observe that and imitate that inside our new class, making appropriate changes. So we want private int. We're obviously not going to call the field balance, because balance is appropriate for a ticket machine, but not for a population counting class. So let's call this field count, because it's going to store a count of how many people are currently inhabiting the town. So now we've got a field. If we want to check to make sure that we've got all the elements correct, then we might choose to compile the class at this stage. We get no indications in the left-hand margin that there are any problems, so we can now be confident to proceed further with the definition of our class. So the next stage to think about is, when an instance of this class is created, what do we want the initial state of that object to be? Now, a town is going to have a population at the point that one of these signs is installed. So we don't simply want to initialize the count to be 0. Ideally, we'd like to initialize the count to be whatever the current population of the town is. And of course, every town will have its own unique population count. So we can't simply hardwire a particular value for the count inside the constructor. We need to receive information to the constructor to tell this particular instance what the current population count is for the town it's representing. And that suggests that what we want is a parameter. So let's define our constructor. The constructor has the word public in front of it, then it has the same name as the class. We'll work out what to put in the parameter in a moment. Let's just get the outline of the constructor. And now let's think about how we're going to initialize the value of the count field. So we clearly want a numeric value to be passed in. So we want the parameter to have the type int, and now we need to give a name to the initial value of the population count. We want a name that's distinct from the field because we want to be clear which is the parameter and which is the field. So let's call this initial count. And once again, I observe the convention of camel case, which is to make the C of count, the second word, an uppercase C. So now inside the body of the constructor, I want to initialize the count field, and I want to store into it the value that's been received in the initial count parameter. So if we're not quite sure how to do that, we might refer over to the ticket machine class, which has a similar form where there's a parameter value coming in, and that parameter value is being used to initialize the value of the price field. So making the appropriate adjustments for this class, it's the count field that we want to initialize, and on the right hand side of the assignment symbol we want to copy the value that's been passed in via the parameter to the population. So let's check to see whether that compiles all right. Maybe now's the time to create an instance in order to see whether a field exists and is being initialized correctly. So let's create an instance of the population, and let's say the initial value is 500. Bring up an inspector. There's our field, int count, and indeed it's been given the initial value of 500 as we would have expected. And if we want to gain confidence that this is all working properly, we can create another instance, and this time maybe the population is 900. Bring up the inspector, and indeed the initial value of the count field is 900. So we seem to be doing okay in terms of defining our field, our constructor, receiving a parameter to initialize that field. Next step is to think about a getter method for this field. And once again, we can refer to our ticket machine source code. Here's our getter method for price. We can follow exactly the same style in defining our getter method for a population count. So we want public. The return type of the getter is the same as the type of the field that it's returning. So we want int in there. Getter methods typically start with the word get followed by the name of the field suitably converted to camel case. So we'll call this get count. Getter methods typically don't take any parameters, so we have an empty pair of parentheses. And now the body of the method simply needs to contain the word return followed by the name of the field whose value it is that we're returning. So here's an accessor method for the count field. Let's compile. Everything's fine. Let's check to make sure that our accessor method is working as it should. So we should expect to get the value 500 returned from calling getCount, and indeed we do get 500. So everything's going fine so far. So let's review. We've used as a reference our ticket machine class to help us with remembering the form of fields and constructors, to check how to make an assignment to initialize a field. We've used it to review the source code of an accessor method so that we can write something similar in our own class. So perhaps now is the time to think about expanding the number of fields in order to support the idea that a population object will also store the name of the town. Now the name of the town is not going to be an integer value, it's going to be a piece of text, or in Java data type terms it's going to be a string. So let's add a field, and again we're going to make the appropriate adjustments. So instead of type int, we want type string, and let's use the variable name town to refer to the fact that this is going to store the name of the town. An alternative might have been simply name, or even name of town. Something descriptive to make it clear what it is that the field is going to be storing. Just as we required a parameter to initialize the count field, we're also going to need a parameter that receives the name of the town that this population object is going to be representing. So we can add a further parameter into the header of the constructor by saying what type of value is going to be received. We want to receive a string, and we need to give a name for that parameter. So let's call it town name. Again, to make a distinction between the field and the parameter. And just as we did here, to initialize the count field, we used an assignment statement taking the parameter on the right hand side. We're going to do exactly the same to initialize the name of the town. So town is going to be initialized by assigning to it the value received by the parameter town name. And again, we can compile at this stage and check things out. We haven't got an accessor method yet, but we can still use the inspector to see whether we've initialized correctly. So we'll create a population instance, and of course this time we're now asked to provide two values, two parameter values. So we'll provide the value 500 there, and our string, remember starting with double quotes, we're going to call small town. Click on OK, bring up the inspector, and everything's looking good. 500 for the initial count, and the small town string that we passed in as a parameter has indeed been assigned to the instance variable town. So there's nothing to stop us now from proceeding to add the getter method for town. Once again, it's not going to be identical to this method here that's returning an int. We need to make appropriate adjustments, but it's going to have exactly the same form. The only thing we need to remember is that the return type needs to match the type of the instance variable that it's returning. So public, and now string get town, no parameters. Inside the body of the method we write return town, because that's the name of the variable that we want to be returning from this method. And again, we can go through the compilation process, create an instance, just to give us confidence that each step that we're taking is giving us the results that we expect. And indeed, small town, the value of the town field, has been returned. So everything's looking good so far. We've modeled our class very closely on elements of the ticket machine that we've already seen, but we've made appropriate adjustments to fit differences such as data types, numbers of parameters required, and return types. So now it's time to think about how the town might register the fact that there have been new births and new deaths. So let's take some very simple steps. Let's add a mutator method that's going to change the state of a population object whenever there is a new birth in the town. So essentially what we want is a method that allows the system, in other words the person or the part of the program that's registering births, to say to the population object, there's been a new birth, you need to update the count so that the electronic sign will now reflect the fact that there are more people in the town. So let's write a method that will alter the value of count. I'm going to start very simply. We're going to write a method that will simply add 1 to the value of the count whenever there's a new birth. So we're going to use public for the method. Is the method going to return anything? Well, no, it's not. We're simply asking the population object to change its state. So we don't need to return anything. We can use the word void. What are we going to call the method? Well, let's pick a name that represents what's going on, which is that there's been a new birth. We'll call it birth. And now the question is, do we need to pass a parameter into this method? Now, at first sight, it might appear that actually we do need to pass a parameter. We need to tell the object how many births there have been. But actually, in this particular case, we're writing this method specifically to add 1 to the population count because there has been 1 new birth. So it's not necessary to pass a value in as a parameter because the method already knows, in a sense, that the value 1 has to be added to the count. So in this particular case, we won't pass a parameter in. We'll simply write an assignment statement inside the body of the method where we want to make a change to the current count, and the change we want to make is to compute the result of adding 1 to the current value stored in count. If we're not quite sure how to do that, then we can refer again over to the ticket machine class, and here's an example where we change the value in balance by looking at what the current value in balance is and adding to it some additional number. Now in our case, that initial number is going to be 1. So we can imitate this form here, making appropriate changes, and say that count is to be the current value plus 1. So we make an assignment to this variable of the current value plus 1, and whatever that sum is will now overwrite the previous value of the count. So let's check to see whether that's working as we would want it to. We'll create a new population object, initial population 500, small town. We'll bring up the inspector, and then we'll call the birth method. And of course what we're expecting is that the value over here will be increased from 500 to 501. So let's see whether that actually happens. We call birth, and indeed the 500 is now 501. Let's call it again, and each time we call it, the current value is increased by 1 as a result of the assignment statement that's being made here. So we find out what the current value is, we compute the sum of that value plus 1, and then store the result into count. So we can do something similar whenever there's a new death registered. So in this case, we want to subtract 1 from the count. The subtraction operator, the addition operator, we expect the sum here to result in a value that's 1 less than the previous value. So again, let's check that out. Always just taking small steps, checking to make sure that what we've just done produces the result that we anticipated. So new population 500, bring up the inspector and call that death method, and the value goes down to 499. So everything looking good so far. Now I want to introduce you to a new feature of the language where it's quite common to want to add 1 to the value of a variable. That could be an instance variable, it could be some other type of variable. It's a very, very common operation. We might have a counter that we want to gradually increase by 1 over a series of steps. And rather than having to write the assignment in this form, Java provides a shorthand for simply incrementing by 1 the value of a variable. And the way that that's written is to say variable plus plus. So notice that there's no assignment symbol, but actually this statement has exactly the same effect as the assignment that we've replaced it with. So here the value of count will be increased by 1, and analogously we can use minus minus as a way of decrementing a variable. There's no space placed between the two operator symbols, plus plus, minus minus. Let's confirm that that gives the same effect when we create a population object. So birth goes up to 501, death goes down to 500 again. So that's a special symbol that it's worth getting to understand and use whenever you simply want to increment or decrement a variable by 1. Okay, let's think now about how we might produce this kind of effect. Now, here we've got a GUI, much as you might have in an electronic sign, and we're not going to have that in our particular project example, but how might we print out that same information in a similar format from within the population class? Let's look at a method that could print the current population along with the name of the town. So again, we're probably going to want to refer to code that we've seen before. We want to observe the way in which we did printing in the print ticket method of the ticket machine, and remember that we used this idea of string concatenation that enabled us to print out a string followed by a numerical value. And if we take a look at what we've got here, we've got something very similar. We want to print the string population followed by what the current population number is. So we're probably going to reuse that feature of string concatenation when we write a print method in our population class. So let's write a print method that's going to be public. It's not going to return anything because printing is not the same as returning. Always important to remember that. And we're going to call it print current details. So this is the first time really that we've seen a method name where we've got 3 words, and notice that I'm still sticking to the camel case convention that the second and the third word have their initial letter capitalized. So print current details, and what we want the output to look like is we want the name of the town followed by a new line, then the word population, followed by a space, followed by the current count of the population. So let's see how to do that in this method. So we're going to use system.out.println. If you're not confident about typing that out, then you can always use copy and paste from an existing piece of source code. And then we want the name of the town to be printed out first of all. And we remember that this ln will then cause the printing position to move to the beginning of the next line, and so the next thing we print will occur on the line immediately following. So we want the word population. We remember to include a space in order to separate the word population from the actual count, and then we use string concatenation, the plus symbol, followed by the value that we want to print out, which is whatever the value is that's currently stored in the count field. And let's compile to check, close, create a population object, and we can immediately call print current details, and indeed we get small town population 500 printed out, which is the kind of form that we wanted. And so at some point some other part of the program could be added that drives the electronic sign, and we would know that all of the information needed to appear on the sign is available provided by an instance of the population class. So the population class provides an accessor method for the name of the town, an accessor method for the current population count, and all that information could then be displayed on the electronic screen. Before we finish, let's add a little bit more detail to this, or some more convenience methods. Imagine that instead of needing to record one birth at a time or one death at a time, we might want to record multiple births. For instance, if twins have been born, then it would be nice to record that the count has to go up by 2 rather than just 1. Or maybe some registrars gather up their records at the end of the day and pass them on to the electronic sign, and maybe there have been 3, 4 or 5 births in a day. So it would be nice to have a method where we could increase the count by something other than 1 each time. And if we're to do that, then we want something closer to the insert money method over here, where some value is coming in and we're increasing the balance by that number that's come in. So what we want is a method that takes the number of births that there have been that we wish to increase the count by. So we want public, we're not going to return anything, and we're going to call the method births with an integer parameter, and let's say how many. Again, I'll put the brackets in. So following the model that we have for the insert money method, we now want to say count is assigned the value of the current value plus how many. So this calculation is performed and the result is then stored into count. Let's check to make sure that that works okay. And let's say that there have been 4 new births in the town, and indeed our count goes up to 504. And we could obviously do the same with deaths. We could define a deaths method which takes a parameter that then reduces the count by that many. And once again I want to show you a feature of Java that recognizes that we quite often want to increase or decrease the value of a variable by some other value. So this idea of writing a variable on the left hand side of the assignment statement and then that same variable immediately on the right hand side of the assignment statement adjusted by some amount is very common. And so Java provides a way to do that. And in order to show you the difference, I'll add the deaths method. So we might write the deaths are going to be decreased by how many. So similar form to births, but using subtraction instead of addition. So instead of writing it out in this long form, we can actually write it out with a variation of the assignment operator. If we write the plus operator immediately before the assignment symbol, then that's a way of saying I want to increment the value of this variable by whatever is on the right hand side. So that says increase the current value of this variable by the value on the right hand side. And that will give exactly the same effect as saying count is assigned the value of count plus how many. So that's a slightly different form, and again it's very common to see that form in Java source code, so you need to be aware of that and you could potentially write that for yourselves. So if we were to do the same over here, then instead of writing it out in this long form here, we would change it to be count minus, then the assignment symbol, and then how many we want to subtract from this variable. So hopefully that's given you a sense of how we can create a new class from scratch, very much building on what we've seen before. So using the source code of the ticket machine class that we'd written as a guide for how to write the various elements of a new class, the fields, the constructor, the methods, how to receive parameters, how to make assignments to variables, and so on.